Right. Now let us discuss how the soap remove the dirt from the body and from the clothes. Right. So let us discuss cleansing action of soap. Cleansing action or cleansing action of soap. How the soap remove the dirt particles from the clothes and from our body. So soaps are used generally for cleaning our body while doing bathing and to remove the dirt from clothes. How what the mechanism is takes place in case of cleaning process. Let us before that let us understand structure of soap molecule. Structure of a soap molecule. So let us discuss before that. Before cleansing action of soap, let us discuss the structure of a soap molecule. Structure of soap molecule. Soap molecule. As we discussed, soap is a salt of sodium salts or potassium salts of fatty acids or long chain hydrocarbons or long chain carboxylic acid. So A plus COO minus where the structure long chains. So each one acts as one carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17. C17 H35 COO Na. C17 H35 COO Na. Sodium stearate. Sodium stearate. So has a long hydrocarbon chain and a short ionic chain. Short ionic chain. Two parts already we discussed. One is long non-ionic hydrocarbon part. The other one is short ionic part. In that long hydrocarbon part, long hydrocarbon part is called as hydrophobic, non-ionic hydrocarbon part. Non-ionic carbon hydrocarbon. Long non-ionic hydrocarbon part is called acts as a hydrophobic. So chain is a hydrophobic, right? A long non-ionic hydrocarbon part of a soap is hydrophobic. Hydro in the sense water. Hydro in the sense water. Phobic means fear. Phobic means fear. So in a soap, two parts are there. Long non-ionic hydrocarbon part is hydrophobic. Hydro in the sense water. Phobic means fear. Phobic means fear. Right. Then coming to the other one, this part. Short ionic part Office soap is a hydrophilic. Is hydrophilic. Hydro in the sense water. Hydro in the sense water. Philic in the sense love or attraction or affection, whatever the terms you have to use for our understanding. Fear, repel, right? Not affection, has no affection, whatever the terms you have to use for our understanding. But instead of that, to write hydrophobic or hydrophilic. So hydrophobic, water repelling or water fear. Hydrophilic, water attracting, loving the water. Water love. Water can love equality. Then it is a short ionic form because of polar substance. Polar solvents. Polar substances are dissolved in polar solvents. Water is a polar solvent. We already discussed, right? Whereas the ionic hydrocarbons are the non-polar compounds. Non-polar compound does not dissolve in polar compounds like water. They dissolve only in non-organic solvents like benzene, carbon tetrachloride, etc. That's right. So the ionic portion of the molecule is hydrophilic. Hydrophilic, water attracting. Water attracting. Due to the polar nature of water molecules. So the ionic portion of a soap molecule is soluble in water. Then the non-ionic hydrocarbon part is indissolved or non-soluble in water. Keep in mind. From this discussion, we can conclude that the hydrocarbon part of the soap molecule is soluble in oil or grease. So we concluded that this hydrocarbon part is hydrocarbon part of a soap is dissolved or soluble in oil or dirt. Oil or grease. So it can attach to the oil and grease particles present on the dirty clothes. Whereas ionic part of a soap is soluble. Ionic part of a soap is soluble in water. Hydrocarbon part is soluble in oil or grease which are present on the dirty clothes. Then whereas the ionic part of the soap is dissolved or soluble in a water. So these ionic parts are attached to the water molecules in which. So when while using a term. So finally, the short ionic part of the soap molecule is soluble in water. So it can attach to the water particles. Soap is dissolved and dirty clothes are dipped. When we dip the dirty clothes in the soap solution, in the soap water, two parts. Hydrocarbons part, ionic part, short part, long part. Long part is mixed with the dirty particles. Short part is mixed with the water or solution in the soap solution. That's then keeping these two unique properties of soap molecules. What are those two properties? Long non-ionic hydrocarbon part is hydrophobic, means water repel. So these particles are attracted to dirt particles. Whereas short ionic path of soap is hydrophilic, water love, so they are attracted to water particles. By keeping this in mind, we will now explain how soap actually cleans the dirty clothes. So here we have to understand the another important term we can call as micelle. We can call as micelle. So not micelle, marcelle, right? That is not micelle, marcelle. That is micelle. You can call as micelle, right? Micelle is a spherical aggregate of soap. A spherical aggregate of a soap. Aggregate of a soap. How this soap micelle is obtained? Soap molecules in a soap solution in water. So a spherical aggregate of soap molecules in a soap solution in water is called as a micelle. So micelle is one of the example for it is colloid. One of the example for colloid. As you know, colloids, as you already learned in class 9, is matter around us pure chapter. Differences between solutions, suspensions and colloids. So colloid particles are generally float in the solution. Similarly, these spherical aggregate soap molecules are float in the soap solution. Let us know how they are obtained. Let us discuss them. Okay. Micelle, a spherical aggregate of soap molecule in water is called, right? It's nothing but when a soap is dissolved in water, it forms a colloidal suspension, in which the soap molecules are clustered together to form a spherical micelles. Right? So, a spherical aggregate of soap molecule in soap solution in water is called as micelle. It is a colloid. Right? A soap solution appears cloudy. Because of the soap micelles are large enough to scatter the light. So whenever we observe that when a soap is dissolved in a water, we observe a substance which is floating in the water. That is nothing but micelle. In simple. Here, extremely sorry for that. I forgot to say one important term, saponification. While making soap, you need to use the word saponification. Sorry for that, extremely sorry. Saponification is alkaline hydrolysis of triesters of higher fatty acids producing soaps. So alkaline hydrolysis alkaline, alkaline hydrolysis of triesters of fatty acids producing soaps. Simply, the manufacturing of soaps, when fatty acids are reacting with the sodium hydroxide, that process is called as a saponification. So sorry for that, extremely sorry for that. I forgot. Okay, let us understand how this soap clean the dirt. Let us discuss. Right. When a dirty cloth is inserted in the solution, then the hydrocarbon part sticks to the dirt or oil with a little exudation of dirt particles get entrapped by the soap micellar and get dispersed in water, due to which the soap water gets dirty and the clothes gets clean. For example, the solution. So when we place any cloth or that any cloth, right here, okay, this is dirt. This part is a dirt. This is a soap solution. While dissolving, when we add the soap, when a dirty cloth is inserted, in the solution, then the hydrocarbon part sticks to the dirt or oil. So these are all are the soap molecules. In that soap molecules, these are hydrocarbon parts, long chain hydrocarbon parts. This non-ionic hydrocarbon part is hydrophobic. So it cannot move towards the water molecule. So these are moved towards the dirt particles. So slowly coming, and what will happen here? Right, this is the dirt. Then soap solution. Then hydrocarbon parts are combined with, are joined or attracted towards the dirt. So what will happen? These hydrocarbon parts are attracted towards the dirt, and form a spherical aggregate of soap. Nothing but these are formed like a these are forms miceli. These are called miceli. So these all are forms, this kind of structures. Right. So this is micelle. This is micelle. So yeah, this is a micelle, right? So in this way, after see observe that. So when a dirty cloth is added, when dirty cloth is placed in a solution, in a soap solution, so the hydrocarbon part is attracted towards the dirt particles, either oil, some other whatever, because of hydrocarbon part is hydrophobic, water fear, so that's why they transfer this. Then they attracted and they joined with dirt. And after they remove the dirt. They remove the dirt. From cloth. This is a cloth. Here also cloth, right? Here cloth, dirt. So hydrocarbon parts are attracted here. They joined with, then separated from the cloth, right? With the little agitation of the dirt particles get entrapped by the soap micelles and gets dispersed in water, due to which the soap water gets dirty and the clothes gets clean. So when the dirt is removed from the cloth by hydrocarbon parts, then cloth become clean, then the water or the solution become dirt. So in this way, the hydrocarbon part is attracted towards the dirt particles. The dirt particles and the hydrocarbon part are joined, mixed together, forms a colloidal suspension, a type of spherical structure, a type of spherical agitation is formed, that is called as a micelle. Soap has one polar end, nothing but the short end, and one non-polar end, right? The polar end is hydrophilic in nature and this end is attracted towards the water. This part is attracted towards the water, then no problem. Then this part is combined or attracted towards the dirt particles and remove the dirt. The non-polar end is hydrophobic in nature. It is attracted towards the grease or oil on the cloth but not attracted towards the water. When a soap is dissolved in water, the hydrophobic end attracts themselves to dirt and remove it from cloth, right? The hydrophobic end of the soap molecules move towards the dirt or grease particles. The hydrophobic ends attracted to the dirt particles and try to pull out. The molecules of soap surrounded the dirt particles at the center of the cluster and form a spherical structure called micelle. So these are trying to remove the dirt. While doing it gives this type of structure. This type of structure we can call as a micelle. These micelles remain suspended in water like particles in a colloidal solution. So the various micelles present in water do not come together to form a precipitate, as each micelle repels the other because of the non-ionic repulsion. So many micelles are formed but they won't combine each other because they are same. Because they are same, non-ionic. So many layers of micelle are formed. Thus the dirt particles remains trapped in micelles, which remain suspended and are easily rinsed away with water. Hence, the soap micelles remove dirt by dissolving it in water. So, this is a simple way for understanding. And I will show you a picture, easy to understand instead of what you have in your textbook, either the government textbook or the private series textbook. Right? Then. So, we have to also make micelle, how the micelle is formed. Then previously we discussed how the soap is manufactured in the laboratory. Similarly, we have to understand how the micelle or how the soap is acts by making oil and greasy particles mixed with water. Right? Take 10 ml of water in test tube, add little cooking oil. The oil does not mix with water, as we know. It floats. Now put a cork on a test tube. And shake it well for a few minutes. Even then, oil floats and water. Now add a little of soap and shake it again. This time the oil and water mix and they form a milky emulsion. From this we can conclude that the soap has made the oil mix in water. So no problem. Simply how the soap works. So take a test tube. Take water and oil. While we know oil formulated. Then place a rubber cup, shake it again. So again we observe that they did not mix. After we add some soap and mix it, what will happen now? Water and oil mixed together. Nothing but soap is manufactured for mixing the dirt particles with the water. When they are mixed with the dirt particles mixed with the water, by the action of the cleansing action of soap, the dirt is removed from the clothes and removed from the solution, whatever. Right? But here there is some limitation of soap. Because of soaps works excellently in case of soft water. So we have two kinds, soft water and hard water. In case of soft water has no calcium and magnesium salts. Soft water has no calcium and magnesium salts. Soft water has, so here let us discuss limitations of soap. So in case of hard water, means hard water contains calcium and magnesium salts. So if the water is hot, a large amount of soap is wasted. When in case we use soap in case of hard water, a large amount of soap is wasted, because while the soap particles or soaps are reacting with calcium and magnesium salts, which are present in the hard water. So calcium and magnesium ions of hard water to form an insoluble precipitate. In case of hard water, the calcium and magnesium ions forms insoluble insoluble precipitate we can call as before it can be used for the real purpose of washing. So a large amount of soap is needed for washing clothes when the water is hot. When the water is hot. Why? Because of the scum or curdy precipitate. Scum or the curdy precipitate formed by the action of hard water and soap sticks to the clothes being washed and interfaces with the cleaning ability of the additional soap. Simply, this scum is obstruct the cleaning process of soap. So this makes the cleaning of clothes difficulty. So the formation of foam or the lather is necessary for removing dirt from clothes during the washing of clothes. Without forming foam, without forming lather, so we cannot remove the dirt from clothes. While the action of soap in the water while washing the clothes, a foam or the lather is formed. In case of hard water, the scum cannot form the foam properly. So the cleaning process of clothes become very difficult. Right. So in case of soft water does not contain any calcium and magnesium salts of fatty acids. Therefore they form foam easily. So what we get? We can clean the clothes properly. So action of soap is limited only for the soft water because no scum is formed, because no calcium and magnesium salts are present in the soft water. So the action takes place properly, then foam is formed properly, so then we can clean or remove the dirt from the clothes. Right. So this is about the limitations of soap. For that, so to have check it is really hard water. With hard water soap does not clean the dirt from clothes properly or not. So we have to test. With soft water and hard water. So take two test tubes. In the one test tube you have to take distilled water. Then other one also take water by adding any calcium or magnesium salts. If you add any calcium salt or magnesium salt into the water, then it become hard water. And this is a soft water. Then in both test tubes add some soap solution and shake them well. So in one test tube distilled water, then another test tube water, then this water is mixed with any calcium and magnesium salts. In both test tubes we have to add soap solution and mix them. Observe in which test tube we observe foam more, in which test tube we observe foam less. So in which test tube the foam less, that is hard water. In which test tube the foam is more, that is a soft water. So by this we can understand. So soap water cannot remove the dirt in case of hard water. Then soap can remove the dirt from clothes in case of soft water. Right? So in this way we can understand that, okay, understand the cleansing process of soap. Cleansing process of soap. So understand what is micelle. So a spherical aggregate of a soap molecule. Simple. While we are washing the clothes, when the clothes are dipped into a soap solution, we observe some particles or floats in the soap solution. They are simply for understanding. We can say that micelle. Right? I hope understood about cleansing action of soap, saponification, micelle, structure, the limitation of soap. Thank you.